Okay, we are back. I found more, so we are doing more. This one, it's another one of those CLEP study guides, maybe an older one, maybe a newer one, who knows. Somebody uploaded it to this URL. I should also get that, should be linked in the description. It is at Scribd, whatever that is. If you go there, you can view it online. To actually download and print it, you have to jump through some hoops, but we're gonna go through it on the video, so you don't even really have to do that if you don't want to. As before, a lot of these we have gone through already, so those are crossed out, and we will just stick to ones that are new to us. So skipping number 1 because we've seen it before, we're going to go to number 2. And so we're talking the definite integral from -3 to 3 of the square root of 9 minus x squared. And you might say, oh well, to find the definite integral, how are we going to integrate that in order to get the equation? But for this instance, we don't really have to, because if you think of this in terms of y equals the square root of 9 minus x squared, and then we square both sides, y squared equals 9 minus x squared, and then we bounce the x squared to the other side, so y squared plus x squared equals 9, which we also know is 3 squared. You might recognize this as the equation of a circle with a radius of 3. And also because it's just the positive square root, not the plus and minus the square root. We're only talking about the top half of the circle with a radius of 3. So, and radius of 3, so we know definite integral from -3 to +3. So that is just talking the entire top half of the circle, real easy. So we know the area of the circle is pi r squared, and that radius is 3. So it's pi times 9, but then only half of it, so divided by 2. And we see here 9 pi over 2, answer D, and that is what it is. So you occasionally get thrown one like this where you don't really have to do the math, you just have to recognize that they're giving you some kind of obvious shape, and you can find the area an easier way. We had one before like that, where it was just some triangles, and you could have done it the regular way, or you can just realize, hey, there are these triangles, and I know the dimensions of the triangles, and I can find the area of the triangles really quickly. Okay, so the next page, number 3 we've seen before, number 4 we've seen before, number 5 we've done before, 6 and 7, so we get to skip that page entirely. Move on to number 8. That's new to us. So we have f is a function defined by x cubed minus 6x squared minus 15. So what value of x does f have a relative maximum? Okay, so if you can recall, when we're talking about maxima and minima, we're talking about where the first derivative or the slope goes to 0. So we want to find the derivative of that, and then find the the zeros of it. So that equation was x to the third minus 6x squared minus 15. And first derivative, as always, bring the exponent down in front and then subtract 1 from it. So we get 3x squared. Bring the exponent in front. Minus. 6 times 2 is 12. Subtract 1, so it's just x to the first. And then 15 doesn't have an x, so it goes away. So here's your first derivative. And we want to know, where is this equal to 0? Well, we can factor some things out. We have 3x as a common factor, so let's pull out the 3x, and that leaves us x minus 4. And so from this we can tell what will make this 0. If that x is 0, then the whole thing is 0. Or if this x is a 4, then that becomes 0 and the whole thing is 0. So we want x at 0 or 4. Right, and let's see, at what value? Right. So it's going to be one of these. We don't know which one, so let's figure out which one. And let's take our options, plug it back into the original equation. So 0 to the third minus 6 times 0 squared minus 15, or 4 to the third minus 6 times 4 squared minus 15. And so this one is obviously just going to be negative 15. And this one, we can, just to go a little quicker, we can rewrite it another way. We can call that 4 times 16 minus 6 times 16. 16 is 4 squared. And since you have 4 16s minus 6 16s, we can just pull that quickly into negative 2. 16 saves us from working with some of the bigger numbers. So it can be negative 32 minus 15. But we can already see that this is going to be, well, it's going to be negative 47. It's going to be a number that is less than this one. So even though they're both negative numbers, the function at x equals 0 is high, and the function at x equals 4 is low. So where it's low at x equals 4 and y equals negative 47, that is definitely not going to be a maximum. So the only option left is where x equals 0 as the probable maximum. So where x is 0, 0 is option C, and that is correct. So moving on from there, number 9, number 10, we've done those before. Number 11, number 12, we've done those before. So moving on to the next page, 13, 14, 15, 16, we've all done before. 17 is new, so let's do that one. So we have a function x times the square root 3x squared plus 1, and question is simple, just find the derivative of that. but that's pretty messy, right? So we're going to have to do some chain rule stuff to that. Right, so we have x times the square root of 3x squared plus 1. And you could maybe do some kind of, product rule thing with this. But I think it's easier to just take, that x by itself is the same as the square root of x squared. And having done that, you can multiply that through and just turn it into the square root of the square root of 3x to the fourth plus x squared. And then, of course, because we're going to be doing derivative stuff with it, we are going to convert that square root into an exponent of 1/2. Okay, and now comes the chain rule part, where when you have a thing inside of another thing, an equation that is f of the g of x, that the derivative of that is f of the original g times the derivative of f of the original g times the derivative of the g. And in this case, f is just the square root. So the derivative of the x is going to be half comes down, subtract 1 from the half, you get negative half. And then our g is the inside stuff, so 3x to the fourth plus x squared. And then the derivative of the g, easy usual stuff. Bring the 4 down, multiply with the 3, 12. X to the power of 4 minus 1 is 3, plus, bring the exponent down, is 2. X to the power, 2 minus 1 is just 1. So 12x to the third plus 2x. Okay, so let's carry that through using the chain rule formula. So we have the derivative of f 1/2 of the original g to the negative 1/2. So we'll fill in the original g, 3x to the fourth plus x squared. And then we multiply that by the derivative of the inside, the g, times 12x cubed plus 2x. And, well, we can clean this up a little bit. We know that when you have a negative exponent, that means it's reciprocal, so it goes underneath. So we have the 1/2, 3x to the fourth plus x squared to the 1/2 power. And then we can just pull that on top because it's multiplying. 12x cubed plus 2x. And we can do even more cleanup on this. First of all, let's note that we have common factor here. That's the 2x. So we have 1/2. And we're going to pull out a 2x. And that leaves us with 6x squared plus 1, like that. And then on the bottom, we have a common factor in here of that x squared, just like we inserted the x squared into things up here. We're going to do the reverse, and we're going to pull it out. So it's you separate out an x squared, take the square root of it, and it's just an x by itself. And then I'm going to change the half exponent back into a radical. And we're going to have 3x squared plus 1. And then if you look, we have 2x up here and a 2x down here. So those cancel each other out. And you're just left with 6x squared plus 1 on top, and square root of 3x squared minus 1 on the bottom. And wouldn't you know it, that is present in the options as answer D. So that is the answer. So just, factor in, factor out, do the chain rule, just, things like that you need to be prepared to do, just arrange things so that it's easier to do the calculus, and then factor things out to get the simpler version of the answer, which is what they're going to be looking for in the selection of possible answers. Okay, and we have 18, 19 that we've done before. Here's number 20. And this one is not a multiple choice. We just find the number and write it in the blank. So let's go after that. So we're talking about a definite integral from 0 to 1 of the nth root of x minus x to the n dx, and we're saying that all of that equals 3/4 for some value of n. What value of n is that going to be? So let's first get rid of that radical so that we can work with it a little bit. So it's going to be x to the power of 1 over n. Square root 1 over 2, cube root 1 over 3. So the nth root is 1 over n. And minus n squared. So now we need to figure out, we need to take the integral, from what would you take a derivative to get to this? And that's just our standard power rules in reverse, right? So if you are taking the derivative of something to get to x to the 1 over n power, remember you took the exponent down and then subtracted 1. So we're going to have x to the 1 over n plus 1. And it's going to be multiplied by, divided by. I'm going to write it with a -1 exponent, so that when you take the derivative of this moves over here, cancels out, and you subtract the 1, and you get the 1 over n that you started with. And so the same thing here, where you have the n plus 1 x to the power of n plus 1. Because when you take the derivative, that moves down there, cancels that out, then you subtract 1, and you get the x to the n. And, we've done this before with real numbers in there, and we're just doing this in a very general way with the variable n being in there. somehow equal to 3/4. So normally this would be, well, we're doing the definite integral. So you would do, filling in x with the 1, calculate it all out, and then subtract from that the same thing, filling in the x for the 0. But we notice right away that when we fill in the x to the 0, it all goes to 0. 0 to the power of whatever is still 0. So that's meaningless. It all goes away. And we're just asking ourselves, what does it turn into when x equals 1? But we can also see from that if x equals 1, 1 to the power of whatever is always still going to be just 1. So we can kind of ignore the x's as well, and it just very quickly resolves into 1/1 plus 1 minus 1 plus 1 to -1, and I'm going to convert that to the more familiar notation now. And we can see that 1/1 is that's just 1. 1 plus 1 is just 2. So we have 1/2 minus 1/2. No, I did that wrong. Where did I go wrong? I did that. Where did I go wrong? Right. I mixed up the n with the x. I filled in. We were good until there. The 1 goes into the x's, but the n is what we're solving for. Okay, so again, the 1 goes into the x, those goes away, and we are left with the 1/n plus 1 minus 1/n plus 1 equals 3/4. Now we have to solve for n. All the x's and the definite integral stuff, we've moved that out of the way, and now we just need to solve for n. So how we do that, we are going to start down here. We need to add 1/n plus 1, and the best way to do that is to take our 1 and convert it to n/n. And then we still have this here. So that becomes 1 plus n/n. Still this. And when you have a fraction under a fraction, that means you can just flip the whole thing over. 1 divided by 1/2 equals 2. So we're going to flip the whole thing over. N over 1 plus n minus 1 equals 3/4. And now we have a common denominator. So we can bring the top pieces together, equals 3/4. So now, n minus 1 over n plus 1 equals 3/4. And we could do more math with this, multiply both sides by n plus 1 and do other math things to solve for that. But if we recognize that 3 over 4 is the same as 6 over 8, now it should be more obvious fairly quickly that n is going to be 7, because 7 minus 1 is 6 over 7 plus 1 is 8, and n equals 7 gives you the 6 over 8, which is equal to the 3/4. Yeah, we could have, solving that algebraically, I'm sure would have worked, but that would have taken longer than just recognizing, n minus 1 over n plus 1. You can kind of guess and check that fairly quickly. So n equals 7. There we go. Sorry for derailing myself in the middle there. Lost track of what I was doing. Moving on, 22 we've done before. 23. We'll do 23 and let f be the function, which is 2x minus 4 for wherever x is greater than a, and x squared minus 2x minus 1 wherever x is less than a or x is greater than or equal to a. So basically, you're moving along as x, and then you reach whatever value a is, and you switch off from this equation to that equation. And so for what values of a is f continuous, and by continuous we mean they meet up. It doesn't, at a, you don't jump from one x value to another x value. It's the same x value. So the real question here, after all that fancy language, we're saying for what value of x are these two functions crossing each other, which will enable you to hop off of one and onto the other without jumping any gaps. So that's a fairly straightforward algebra issue. Where is one equal to the other? And then we can bring those over here. 0 equals x squared minus 4x minus 2x again. And then we're adding 4 to both sides, so negative 1 plus 4 is 3. And then, you could quadratic equation this if you wanted to, but it's simple enough that really should be able to factor it out. What multiplies to a positive 3 but adds to a negative 4? We think that is going to be negative 1 and negative 3. So our options for the value of a are going to be x equals 1 or x equals 3. And that is option D. Those are the two options. Either one of those filled in for A will make that continuous, where you can switch evenly from one function to another. So that was fairly simple one. Quick and simple. 24, another one that we've seen before. We're going to skip it and move on. 25, 26, 27, 28, all we've seen before. Here's 29, so we will do that one. And again, no multiple choice, just to fill in the blank. So we get to work it that way. And it was saying for some constant c, we have the equation y equals 4x plus c. So what is c going to be? And that line is tangent to the graph with the function f equals x squared plus 2. So by tangent, we mean it has the same slope at the point where it meets. The slope of this is going to match the slope of that at wherever they meet. So we recognize, we know from algebra, if you remember the old y equals mx plus b equation, where the m is the slope and the b is the y-intercept. So we know right away we're talking a slope of 4. So we need to know where these are meeting. So we need to figure out where on this is the slope 4. So that's going to be the derivative. So we have f of x equals x squared plus 2. And we need to know the derivative. So a pretty straightforward one. Bring the 2 down. 2x, 2 minus 1 is 1. And the 2 doesn't have an x on it, so it just goes away completely. So where is this going to be equal to 4? Obviously at x equals 2. And so what are the coordinates of that going to be? We know it's going to be the x coordinate of 2. And if we plug the 2 back into here, the original equation, 2 squared is 4 plus 2 makes 6. So the y coordinate is 6. So we're going to have the meeting point between the function and the tangent line is going to be at the coordinate of 2 and 6. So now we need to know, we can use that information to figure out what that c is, that y-intercept, y equals 4x plus c, where y is 6 and x is 2. And that's 6 equals 8 plus c. And obviously c is going to have to be negative 2 for that to work out. So we fill in negative 2, and that's what it is. With the fill in negative 2 there, and then they're going to meet at 2, 6 with the slope of 4. And we will deal with the next one in the next video.